Hello everybody and welcome to 4.10 where we are going to discuss connecting the geometry we've been learning to data analysis and some other maths that you may have or have not seen so far in your math career. First thing you want to do is open up the worksheet and make sure you do get yourself a copy of it, whether it is just typing along with the document as you go, printing it out and handwriting on it, just having a piece of paper that you are copying down your notes on as you go, that's fine, but just make sure you have a copy that's handy to refer to. So what we have here is basically a table of x values and what its corresponding supplementary angle measure would be. So if you have 30 degrees, if you take 180 minus 30 degrees, then you get 150 degrees. So we just have a sampling here of some angles and their supplements. And so we do have some questions that we'd want to go through as we go. So number one, are what 2 points can you use to determine the slope? After you identify 2 points that you would like to use, I would like for you to then determine the slope. So use your slope formula. Based on the line of best fit that we discuss in just a moment in class here, what is the y-intercept look like it's going to be for that line of best fit? Given the y-intercept and the slope that you identified in numbers 2 and 3, what is an equation for this line of best fit? This is where you can use the slope-intercept form, y equals mx plus b. And then, once we have that equation, you can use it to predict the supplement of any given angle, and in particular, I'd like for you to practice using it to find the supplement of the angle 165 degrees. So if your x value for your newly found equation is 165. So what we're going to do is I'm going to use my favorite graphing utility, which is Desmos. And we are going to go to table mode. So you guys can always change up here and go to table mode and input our values. So 30, 60, 90, 120, 150, and then 150, 120, 190, 60, and 30. So if you're doing this at home, you may have to scroll in or out to be able to go all the way up to 150 to see the appropriate points, but we should have 1, 2, 3, 4, 5 points visible, which is what we do have here. So this is essentially a scatter plot. So what we want to do is sketch a line of best fit over top. So for that, we need, I'm just going to use a Word document here, and I'm going to, this way it can be a perfectly straight line as opposed to an approximately straight line by sketching it by hand. So this is not fit well yet. I still have some manipulating to do. I just want to make this line a little darker for us to see. And so if you're doing this at home, say you were plotting these points on graph paper, you do want to use a straight edge, so a ruler or the edge of a notebook or something like that, and get a line that fits right through all these points. And these points do look like they line up in a pretty good straight line, so you should be able to get a pretty good line of best fit there. All right, so if you're following along on your notes page, you can identify any 2 points that you wish from the graph. So we can click on any of these points. Let's say this point, okay, 30, 150. So let's use 30 and 150. And again, you can use any 2 points that you'd like. Okay, you can use any 2 points that you'd like. And then another option, no, let's do this first one. Let's do the second one here. That is 120, 60. So this point will be 120, 60. So slope formula, if we recall, was m equals y2 minus y1 divided by x2 minus x1. So in this case, that is going to be, we can do 150 minus 60 and divide that by 30 minus 120. So now we're going to want to do some simplification. So you guys are certainly welcome to use a calculator. You may use mental math. You can use scratch paper. But we do want to figure out what 150 minus 60 is. So after some quick calculations, that is 90. And then 30 minus 120 gives you negative 90. Okay, so 90 divided by 90 is itself, and a positive divided by a negative is negative. And so we have, 90, anything divided by itself is 1. So 90 divided by negative 90 gives us negative 1. So for this line of best fit, our slope is going to be negative 1. Now, with that, we definitely want to keep that information. And that makes sense because if we look back at our line of best fit, it was going downward from left to right. So that tells us a negative slope, which means we probably want and definitely want a negative value for that slope. Next thing we need to identify is a y-intercept. So if we're looking here, we're curious about where this intersects. So if we do 150, 160, 170, 180, this line looks like it cuts across at 180. So that means our b value is equal to 180. Or you could think of the point 0, 180. So if we use our slope-intercept form, y equals mx plus b, we can substitute in our m, which is slope, negative 1, times x plus, and our b value is 180. And so now, for any x value you choose, you can substitute it into this equation and determine what the corresponding supplementary angle would be. So for example, let's say we were curious about 147 degrees. So x equals 147 degrees. So we're substituting that into our equation. So negative 1 times 147 is negative 147. A little typo there. There we go. So negative 147 and plus 180. So negative 147 plus 180, that's the same thing as 180 minus 147. That leaves us with 33 degrees. Likewise, you can certainly take your equation and substitute it into an expression. And we said negative x plus 180 degrees. And look, that line does go through our points that we had before. And then you can click on the line anywhere and see what the x and y values are. Thank you guys for your attention today, and let me know if you need any help.